what we're going to look at now is just quickly look at all these other details just so we can understand what we're looking at and why we're looking at them. I'm just going to kind of go across the top of this detail sheet. We've already looked at detail number 1, typical exterior footing. This actually goes with this, so we'll get to that in a minute. That's detail number 2 that we looked at, CMU wall footing, interior of the store, exterior sidewalk with a footing. Now we're going to move on to number 3 right here. So this would be detail number 3 on S2. It's actually found right down here. This is on the exterior sidewalk. This is the sidewalk coming down. It slopes. The reason that's sloped is to keep, when it rains, keep the water draining away from the front of the building. And so the concrete itself is sloped to create that drainage. But this is a section of the masonry wrapped column. This column right out here, they don't really depict it as CMU, but what it's supposed to be is you have a square right here. You have this square that you're seeing. Right in the middle there's a small steel column. So what this is supposed to be is CMU. Oh, if they would have done it correctly, they would have hatched all this in the same pattern, so we would know just by looking at it that that's CMU. But this is the column coming down, the anchor bolts that are holding it into the concrete, and that's pretty typical. You would have anchor bolts. These are just small curved pieces of rebar that are threaded on top. They're embedded into the concrete, sticking up just a little bit. Column comes down over it. There's a plate on the bottom of the column. Column sits down over those, and nuts are put on to hold that column in place. So that's typically how it's going to be done. But then in this case, once this column is put up, we have CMU wrapped all around it. It has rebar going up into it, again, to make that connection good and solid. Rebar going all the way up through these. And it's just wrapped in concrete block just for the look of it, more or less, instead of having just an exposed steel column. Different ways to do it. They just chose to use CMU. And a lot of times on details you'll see these types of notes: C plan, scheduled footing. So what they're doing is saying, look, I don't want to take the time to change this number every time my detail changes, so I'm going to put this on here. So you need to go back to the plan and look and see what footing is this. Well, that's F4.3. So now I know to look at my schedule, see what size that's supposed to be. I just don't want to put it on here because this typical detail may be used on 5 or 10 different projects, and this may keep changing depending on the load it carries or the soil it's in. So that's why they do that, so they can use this numerous times. Schedule, footing, depth. These are all numbers or notes rather that are typical, and I can put on any project. As long as I keep the notes general like this, then I can just change them on the plan and be done. So that's why they do that. This is referencing the column grid that this particular column falls on, the center line of it, how far to either side this is going to come out, where the top of the building is, the slab on grade. So it's 2 inches at this point. It's 2 inches higher than the end of the slab right here. And this is a maximum of 4 inches, and this is supposed to represent the parking lot. So a lot of different things going on here. Detail number 4, we'll have to hunt it down real quick. I saw one over here somewhere. There's a 4S2 right there. So what that, and one thing if you'll notice, this 4 right here on S2 is actually pointing this way, which would put the outside of the slab on your left side, which is correct. This is the outside of the slab right here. So this is correct. You know, it's opposite of these, but it's fine as long as the detail is correct. This is just, again, showing where the column's coming down, hitting the built-up footing underneath the column, which is resting on the spot footing that we've already talked about. All the dark lines are the rebar that are run through all the different layers of concrete to tie them all together. That's what they're there for. The small dots are rebar running at you That's just representing the diameter of the rebar that's running through that concrete. And it tells you that, hey, there's 3 number 5 rebars, 1, 2, 3. They're all number 5 in size. And they are going the column footing width. It's 6 inches. So basically what they're saying is this may vary, but there's going to be 3 of them. And depending on the column width, minus 6 inches, that's where they're going to be spaced. Why is it minus 6 inches? Because if you remember on the other detail, it was saying that we had to have a minimum of 3 inches clear space between the edge of the slab and where the rebar started. So 3 over here and 3 over here would be 6 inches. So what you do is you say, well, how wide is this? You go find that on the detail or on the plan. And let's say it's 2.5 feet wide. So then we subtract 6 inches from it. So from here to here, it needs to be 2 feet, and they need to be evenly spaced. But there's 3 number 5s. 1, 2, 3 number 5s from here to here, evenly spaced. 3 inches left over out here. 3 inches left over out here. This where it says hairpin centered in slab. If you notice, right here, you have this kind of V-shaped right here. That is rebar, and what it's doing is it's running around horizontal. It's laid horizontal, laid flat in the slab, and it runs back around this anchor bolt and then back out the other way to make this V shape. It's just a way that structural engineers use to reinforce this connection inside of that slab. And what it does, it helps prevent tilting and uplift on these columns. So that's what that is for. But you can see there's notes about the column base plate. That's what this is talking about, base plate, and anchor bolts by others. And what that means is they're not taking care of it. This is something that is pre-manufactured and getting shipped in, so they're not really sizing these. On non-shrink grout, and we'll get into a lot of this when it comes to steel in particular. We're just kind of running through structural plans right now. But I just want to kind of give you an idea of what we're looking at. Excuse me. 5, we've already looked at 5. This is a interior column, and this is a front view, so to speak, and a top view, just to show us how this column is set on the footing. So again, schedule the footing width, see the schedule for footing width. This is a top view showing us that it is a round tube column. Again, column by others. They're not specifying size. It's going to be done outside of these drawings and shipped, ready to go. What this is doing though is showing you this area around the base of the column. What they're doing is they are intentionally leaving this area unfilled when they first pour the slab, so the column can come down inside of this area and attach to the anchor bolts right here. And then once that is done, then they will fill this pocket, okay, with non-shrink grout, okay, after the column is installed. Basically what they're doing is they're just filling this with a lighter weight concrete to help hide all those bolts and make it a clean connection. But the reason they do this, and this is the shape of it up here, it's kind of a diamond shape, and this is telling the size of it. The reason they do this is so that if something ever happens, they have to do something with this column, replace it or whatever, they can just break up all this grout around the actual column base and do something with it without having to literally destroy the slab and then patch it or repair it. So this just comes out, they break it all up, fix it, pour it back, and you're done. This is just a typical look at how they want the CMU to be placed around the columns. This is that hairpin, number 6 rebar, how they want it placed around the anchor bolts in the slab. And again, this is a top view. And then this is pretty typical. Excuse me. This is a concrete block wall out there on the front, but this is where a door and a window will go. Okay, and so what they're doing is they're showing how they want the wall reinforced. Everything shaded is going to be filled with concrete. Okay, and all these little lines are rebar. So what they're doing is, as they're building this wall and they know how big the window and the door are going to be, they're leaving that void, of course. Well, right around the door and the window opening and all across the top of it is going to be filled with concrete and rebar. And then every so often around it, you're going to have these individual little columns inside of the cells of the CMU that have a rebar coming up through them, and they're going to be filled with concrete or with grout. Grout, when they say grout, it's not like the grout you use to lay brick. It's kind of a halfway point between that grout and actual concrete. It's like a lightweight concrete or a heavy grout. But that's what all these are. These are pilasters, is what some people refer to them as. It's just filling the cells of the concrete block to where inside of the concrete block, even though you can't see it, because you've got CMU filled with lightweight concrete or grout and rebar, really what you've done is created a column in there to carry some weight. And so that happens inside of the CMU and you don't even really see it. But that's what this is doing. And then this little detail right here below it is showing some of that, and also a control joint in the CMU, showing how they want you to do that. So these are the cells of the CMU filled with grout. There's the rebar coming up, and then sometimes they'll have a place where the concrete block starts and stops again, just like pouring a concrete slab. And inside of that would be the control joint, or the expansion joint, sometimes we call it, to allow for heat and cold when that concrete starts expanding and contracting so they don't crack. But there's a pre-molded insert that you put in, then you're going to caulk the outside and inside. So it just gives details about how they want you to take care of that particular joint. And there's the jamb detail, which is just the side of the window or door, how they want it to be built. Slab on grade control joints, how they want, this is the control joint, that's the construction joint, how they want all that to be done. And this is a section of that CMU wall at that opening we were talking about. This is where the window will go right here. So underneath it, we're going to have some CMU filled with concrete or grout. Above it, we will as well. And then we're going to have some more details, where we have the structure connecting to it and all that stuff. And again, a lot of these we'll get more into as we start drawing them. I just kind of wanted to let you see them. Section at a loading dock, it's usually thicker, reinforced, heavier. What we call piers, which are just built up columns basically in the slab to carry different loads. And then we have this again. So that pretty much concludes this little section. And I will probably have one more for you of a different project just to kind of get a different look at some things.